Hello, listeners. Welcome back to the Cyber Mindset. We are Sam and Chloe.
Yeah, thanks for joining us, everyone. Today, we are jumping into a deep dive on something that, honestly, most of us just completely take for granted.
Right. I mean, you're shopping online or you're updating your phone, and you just sort of assume the connection is safe, right? Because
Yeah.
there's a little padlock icon in the browser.
Exactly. But if you look back at the source material, there was this massive incident in 2011 with a company called DigiNotar.
Oh, wow. Yeah. The incident in Iran, right?
Yeah. Hundreds of thousands of users in Iran thought they were securely logging into their Gmail accounts. I mean, the padlock icon was there, the certificates looked perfectly fine.
But they were actually handing their passwords directly to state-sponsored hackers.
Exactly.
Yeah.
All because one tiny official ID office in the Netherlands got completely compromised.
Which is just wild to think about. So that really sets the mission for our deep dive today. We want to give you, the listener, a high-level, practical understanding of how digital trust actually works under the hood.
Right. We're decoding the original source material to really build a cyber mindset around the chain of trust. You know, signatures, certificates, and code signing.
Yeah, think of us as your study partners for the next few minutes. We're getting into the raw mechanics here because, we really can't trust the internet until we can prove a message or a file actually came from who it claims to be from, right?
Absolutely. And that it hasn't been tampered with along the way. Because the internet is fundamentally just hostile territory.
So true. So let's start with the first piece of the puzzle. The source material breaks down digital signatures into a two-step process using asymmetric cryptography. Okay, let's unpack this. The first step is hashing, right?
Right, hashing. You're basically taking a digital snapshot, like a message digest, for integrity.
Okay, so it's a snapshot of the exact data.
Yeah. And the math here is extremely sensitive. If even a single bit of a massive file changes during transit.
The hash changes completely.
Entirely. It's totally unrecognizable from the original hash. So that's step one. Then step two is encryption. You encrypt that specific hash with your private key.
Okay, I actually love using the wax seal analogy for this.
Oh, yeah. Let's hear it.
So imagine the private key is my own unique signet ring, right? I use that ring to stamp a wax seal directly onto the message digest.
Right, I like that.
And then the public key is basically just a widely shared picture of my ring. So literally anyone in the world can use that public picture to look at the seal on the message and verify, that it's unbroken and totally authentic.
That is exactly how it functions. And so what of all this, why organizations care so much, is a legal and technical concept called non-repudiation.
Non-repudiation, meaning you can't deny it.
Exactly. Because your private key, your signet ring, is solely in your possession. The math proves that you, and only you, could have stamped that seal.
Oh, wow. So you literally cannot deny sending the message.
Right. You were legally down to it, which is great for trust, but terrifying if your private key ever gets stolen by a hacker.
Because then the math testifies against you.
Exactly.
Okay, but wait, let me push back logically on something here.
Go for it.
If anyone can just hand me a public key, like a picture of a ring, how do you know that picture actually belongs to my bank? And not just, some scammer who made their own ring.
Yeah.
Yeah.
That is the key distribution problem.
Right.
It's basically the most fragile link in this whole architecture.
Mm.
So to solve it, the industry uses digital certificates. And instead of everyone just kind of making up their own rules, there's actually an international rule book called X.509.
X.509, yeah.
Yeah, and that rule book makes sure all these digital passports work together globally across all operating systems and browsers.
Okay, so if the signature is the wax seal, the digital certificate is basically an official passport.
Yes. That's a perfect analogy. And what's fascinating here is that this passport doesn't just come out of nowhere. It is officially issued by a certificate authority, or a CA.
Right, like those companies, Trust or DigiCert.
Exactly. The CA acts as the root of trust. They are the official passport agency. They do the background checks, and they officially vouch for the identity of the key owner.
So they're the ones stamping the passport saying, yes, this public key actually belongs to Chase Bank.
You got it. They bind the identity to the key.
Okay, so now we have secure messages with the wax seal, and we have official passports verifying identities.
But how does this apply to, the software we actually use every day?
Well, think about when you download something.
Like a new app or installing a phone update. How do you know the software itself hasn't been poisoned with malware while it was downloading?
Exactly. Securing the tunnel is great, but if the payload inside the tunnel is malicious, it doesn't help you.
Right, which is why I call this next part the software safety badge.
I love that. Code signing.
Yeah, code signing. It's basically putting a safety badge on the code itself.
Right. And the mechanics, based on the source text, are pretty straightforward. The developers finish their code, they hash it, and they sign it with their corporate private key, stamping the wax seal on the software update.
Exactly.
Yeah.
And then your operating system, whether it's Windows or iOS or whatever, it checks the safety badge.
Oh, by using the public key that's inside the developer's digital certificate.
Yes. The OS uses that public key to verify that the update really truly came from Apple or Microsoft and ensures it wasn't modified by unauthorized individuals in transit.
Man, that is so cool. If the badge doesn't match, the OS just blocks the installation.
Completely blocks it.
Okay, let me throw a provocative what-if scenario at you to test this whole system.
Okay, let's hear it.
What happens if I'm sitting at a local coffee shop on, public Wi-Fi, and a hacker intercepts my connection? Like they actively try to swap the bank's public key with their own rogue key.
Okay, so you're talking about a man-in-the-middle attack.
Right, a mid-im attack. In our analogy world, this is basically an attacker trying to hand the bouncer at the club a fake ID.
Yes, a very mathematically complex fake ID, but yes. And the attacker can easily generate that fake certificate. They can even route all your traffic through their own rogue laptop.
But they still fail.
Right.
Because of the root of trust.
They absolutely fail. And if we connect this to the bigger picture, the ultimate defense here is that your browser or your phone already comes preloaded with the public keys of the official ID offices.
The root CAs.
Right. Those root certificates are baked into the device when you buy it. So because the attacker at the coffee shop does not have the CA's offline, highly guarded private key.
They cannot forge the CA signature on their fake certificate.
Exactly. The bouncer looks at the fake ID, realizes the state seal is missing, and just instantly rejects it. The system catches the lie immediately, and your browser blocks the connection with a massive warning screen.
Wow. So even if they control the Wi-Fi router, the cryptography just mathematically locks them out.
It does, unless, of course, the user decides to just click ignore on that massive warning screen.
Which, unfortunately, people do all the time.
All the time.
Well, this has been incredibly clarifying. So just to kind of summarize how this all stacks together, we have digital signatures that act as that unbreakable wax seal for integrity.
Yep.
We have digital certificates that serve as the official passport, verifying who the keys actually belong to.
Right.
And finally, we have code signing, which gives a software safety badge to our apps and updates to ensure they aren't tampered with.
And all three of those stack up to form a really seamless chain of trust that protects us invisibly every single day.
It's an amazing system when you really look at it.
Yeah.
Well, that wraps our deep dive for today. Think about this. We've built an entire global economy on the idea that we can trust a digital passport from someone we've never met. But if you clicked ignore on a certificate warning today just to get to a website faster, did you just let a stranger walk through your front door without checking their ID?